Good morning. Today, inshallah, we're going to talk about the states of matter part 2. Part 2 in the states of matter include expansion and contraction, solubility, and diffusion. First of all, we're going to start with expansion and contraction of matter. As you see in the picture, this is the substance in the solid state where the particles are vibrating in their places. Here, this is the substance in the liquid state where the particles slide over each other. And here, this picture shows the substance in the gas state where the particles move randomly and freely in all the directions. What will happen if we heated or cooled those uh, substances? First of all, if you have a solid, when you heat the solid, the particles inside the solid gain energy, vibrate faster, and get further apart, as you can see. So the solid expands. Make sure that the particles themselves do not expand. It's only the whole substance expands. It expands. How? Because the particles get further apart from each other, but the particles themselves do not expand. They remain the same size. As you see here, the spaces between the solid particles are very small, but in the liquid particles you have more spaces, and in the gas, uh, the spaces between the particles are extremely large. So when you heat a solid or a liquid or a gas, the three of them will expand, but the gases will expand more than the liquid, and the liquid will expand more than the solid. Just the spaces between the particles are going to get bigger. And as the gas particles are moving freely, so the spaces can get much better than the liquid. The spaces will get um, uh, more bigger than the solid, but still the particles will remain bounded to each other, so it's going to expand but up to a limit. Concerning the solid, the spaces will get bigger to a very small extent. The solid expands to a very small extent. This is because the particles remain in their places, so the spaces just will get a little bit bigger because the particles will keep vibrating in their places and will keep touching this. Just the spaces will get a little bit bigger in that. You cannot observe the expansion of solid with your eyes. For example, if you got a metal ball and you heated it, you won't observe this with your eyes. You have to check it with a ring or something. But with your eyes alone, it's going to be difficult to observe it because the solid expands a little bit, something that you cannot observe with your eyes. Okay, let's turn to the real life applications. Um, as you can see, this is a thermometer, a mercury or alcohol. It shows the expansion and contraction of liquids because the particles of the liquid inside the thermometer, if you heat them, they will gain energy, vibrate, move faster, and get further apart, so the liquid will expand. And if you cool them, the particles will lose energy, move slower, and get closer together, so the liquid will contract. This will lead to rise and fall of the mercury and alcohol levels inside the thermometer. Also, the hot air balloon shows the expansion in gases. How? When you heat the air inside the hot air balloon, the air particles will gain energy, move faster, and get further apart. So they will become less dense because, as we said before, the density is how tightly packed the particles are. So when the particles get further apart, they become less dense. So the hot air balloon will float. The problems caused by expansion and contraction, it's buckling in the railway lines. If you didn't leave spaces in the railways, when the metal expands, they will not find a place to expand in, so they will buckle, so they curve to the side. How to solve this problem? By leaving spaces between the railway lines to give a space for the metal to expand. The same, we leave spaces in the bridges to leave spaces for expansion. When you lay the telephone cords or the electric line cords, in summer you have to keep them loose. Why? So that when they contract in winter, they won't snap. If you left them tight in summer. When you contract them in winter, the electric cords will snap, they will cut. We did this last year in the lab. It's the ring and the ball experiment. First of all, you're going to make sure that the ball passes through the ring. Then you're going to heat the ball and try to pass it. It will not pass because the solid expands. The particles will gain energy, vibrate faster, and get further apart. So the solid will expand. It will not pass through the ring. As we said before, the expansion in solid is very limited, so you won't be able to observe it with your eyes. You need to check it by a ring. Okay, if you cool it down again, the solid will contract and it will pass through the ring again. You can cool it down by putting it in ice or cold water. Diffusion. In diffusion, you should use three key terms. What are these key terms? Random, mix, and spread. For example, we're going to take a definition like, for example, when you spray a perfume, first the perfume evaporate and then the perfume particles will start diffusion. So what will happen? The particles will move randomly, mix with the air particles until they spread out even. This means that the particles will move from the region of the high concentration to the region of low concentration until the concentration is the same throughout. The same when you put a drop of ink in water. The ink particles will move randomly, mix with the liquid or the water particles until they spread out even. They will move from the region of high concentration, from where you place drop of ink, from the region where you have too much ink, to the region of low concentration where you have small amount or where you don't have ink at all, until the concentration is the same throughout. If this ink, for example, is blue, you're going to find out that the whole solution turned blue. As you see, diffusion happens from the area of high concentration to the area of low concentration until the concentration is the same throughout. Examples of diffusion is spraying perfume, but actually diffusion doesn't happen in books. The information doesn't move from the area of high concentration to the area of low concentration. Unfortunately, this doesn't happen. Okay, dissolving. When you have a solid that dissolves in a solvent to make a solution, this is called dissolving. The soluble solid, we call it solute. So if the solid dissolved in the solvent, we call it solute. If it doesn't dissolve, we call it an insoluble solid. How do the solute dissolve in the solvent? It fills in the gaps between the solvent particles. For example, as you dissolve tea in water, here the tea particles are the solute. They dissolve in the water, the solvent, to make a solution, which is the tea. Okay, what is solubility? Solubility, it is the amount or the mass of the solute that will dissolve in 100 grams of solvent or of water at a given temperature. You should write it in the definition at a given temperature, because if the temperature changes, the solubility will change. As you see here, when the temperature increases, the amount of sugar, the amount of solute that is able to dissolve in the solvent increases too. What are the factors affecting solubility? You have four factors: temperature, amount of liquid, size of the substance, and stirring. All those factors will increase the solubility. For example, if you increase the temperature, the solubility will increase because the gaps between the solvent particles will get bigger, so you will be able to dissolve more solvent, more solute in the solvent, and also the solute will dissolve quickly. If you increase the amount of liquid, you're increasing the gaps available. So again, the solubility will increase. The size of the substance, of course, which will dissolve faster, sugar powder or sugar cubes? It's sugar powder. Why? Because it has a larger surface area. So as the size of the substance decreases, the solubility increases. Stirring also will make the solubility faster, because you will make the solute particles find the gaps easier between the solvent particles. That's it. The last term that you should know is a saturated solution. A saturated solution is a full solution. A solution is شبعين. All the gaps are filled and it cannot take any more solid. Thank you very much.